Hey, good morning, ladies and gentlemen. I'm back this week. My recorder app works, and so I'm here to talk to you about calculating surface area of pyramids and cones today. So this won't take long, but I want to show you first off. Um, we used to create if we were in school right now, I'd have you create this big old formula sheet. And a pyramid, you can draw this if you want to, or just kind of pay attention or whatever. But a pyramid has one base, and then the other faces are triangles, like we learned about in section 11.1. And so to find the surface area of our pyramids, so what they are they only have one base, and then it's just a bunch of triangles. Well, if you were to break this into a net, right, we would have a base, and then you'd have triangle, 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 triangle. Okay, so the area of these triangles, each of these triangles is 1/2 base times height. So 1/2 times base times height for every one of these triangles. But actually the height of these triangles becomes what we call the slant height of a prism. It's the height of one of these triangles if it were flattened out and laid on the ground. Okay, so the slant height actually becomes really, really important when we're calculating the surface area of a pyramid, and for that matter for a cone as well. Because what we have is we have one base, right, whatever the area of our base is, and we have four triangles. Well, these four triangles all have, right, 1/2 base times height. Well, here's a base of one triangle, here's the base of another triangle, here's the base, and by base we're talking these little b's, and here's the base of the fourth triangle, and all that adds up to the perimeter of what our the base of our pyramid is. So the surface area of a pyramid ends up becoming the following. Okay, write this down, or make sure you have it in your notes. Okay, surface area of a pyramid: one base, capital B, plus a bunch of these 1/2 times base times heights. These triangles add up to be, excuse me, add up to be 1/2 times the perimeter of our base shape times the slant height of our pyramid, because that slant height is the height of these triangles. Okay, so if we're just straight up given a shape that we have these figures, like look at this. Okay, here's a pyramid. It's a regular pyramid, meaning the base shape is a regular polygon. So in this case, it'd be a square. All sides and all angles equal. So we know that's 8, 8, 8, and 8, and then they're all 90-degree angles down there. So that's a square as a base. And so the area of the base plus 1/2 times perimeter of the base times the slant height. So the area of the base would be 64. Buddy, you can't be playing when Daddy's doing this. Okay. Plus 1/2 times the perimeter of the base, which would be 32, 8, 8, 8, and 8, and then the slant height would be 10, and then it's just a calculation. 64 plus 16 times 10, which is 64 plus 160, which is 224. And this is back to units squared, centimeters squared here. This is surface area. Okay, if you have the base dimensions and you have the slant height, this is pretty easy. If you don't have the slant height of your pyramid, pay attention, like this problem right here. Okay, still surface area formula is this. That's a plus sign. But we only have the height of our pyramid. We don't have the slant height. So in order to find that, we're going to draw it. Okay, and then actually what we're going to do is we're going to create this triangle inside the shape, which is a right triangle, by the way. So if we pulled that out, this right here is called the slant height. Lowercase l is how we abbreviate that. Okay, this is 21. And then this side down here, if this is 40, what do you suppose that is right there? That's just half of that. That's 20. Okay, and so we have 20 and 21 as our two sides. And to find our slant height, we're just going to use Pythagorean theorem. Okay, 20 squared plus 21 squared, and then square root it. and we get 29 on the dot. So the slant height is 29 here. So then the area of the base is 40 times 40. It's a square again. Plus 1/2 times perimeter of the base is 160, 40, 40, 40, and 40. 160 times the slant height is 29. And this is calculator work here. 40 times 40 is 1600. 1600 plus 80 times 29, essentially. And the surface area here becomes 3920 square feet, or feet squared. Okay, so if we are not given the slant height, we have to find it using Pythagorean theorem. If we are given the slant height, great, plug it in. Okay, in any case, most of the pyramids that we're going to have to find the surface area of are going to have either a square or a rectangle as its base. If it has a pentagon or something like that, obviously that's a little bit tougher to find the area of the base, but you know back from chapter 11 how to find the area of a regular pentagon anyway. But most of them that we're going to be asked to do are going to have a simple base shape like a square or rectangle. Okay, let's move on to a cone. Cone is super similar, and by the way, here's how you draw a cone. Flatten out a circle, one dot, line, line, jeez, line, line. Then you take your eraser, or you make one of those dots, one of those lines dashed to begin with. Okay, but here's a cone, and a cone, again, still has one base. Okay, but it's a more specific base. It's always going to be a circle. Okay, and then it's still 1/2 times the perimeter of the base times the slant height. But here's the deal about the area of the base. Since it's always going to be a circle, it's always going to be pi r squared. Okay, and then the perimeter of the base is the circumference of the circle. So we could write CL if we wanted to instead of PL. But we already know what the perimeter of the base is always going to be. It's always going to be 2 pi r. Okay, so really what this becomes, and you can write this down, base plus 1/2 CL, or it ends up being pi r squared plus the 1/2 and the 2 cancel each other out. Pi r squared plus pi rl is what the surface area formula for a cone is. Okay, so if you go to a cone and we're given these dimensions right here, the surface area of this cone is base plus 1/2 times CL, which is pi r squared, plus pi rl, which remember L stands for slant height. The radius is 5, so 25 pi plus pi times 5, and then slant height is something we got to find again, because we have only the height of the cone and not the slant height. So 8 squared plus 5 squared, and then square root that, and you're going to get something a little over 9, I believe. And yes, you're going to get 9.4. So 9.4 is our slant height. All right, now it's just calculator work after that. 25 pi plus pi times 5 times 9.4, and you're going to arrive at 226.19, and we were in inches, I believe. Yes, inches squared. Okay, surface area of pyramids and cones. Okay, this is going to do it for today. Have a great day. Know that an assignment is coming tomorrow about finding surface area of pyramids and cones. Have a great day, guys.